Okay, so let's see if the server is actually booted up again, and we should see that hopefully this problem is fixed now with the vNICs. So let's hit F2 again to log into VMware. Password CCIE DC01, okay, with a capital C, then F2 again. Then we're going to go to Configure Management Network, Network Adapters, and we now see that the MAC addresses are the reverse order that they previously were. Okay, it now shows 8F first and then 9F afterwards, where 8F we saw was mapping to our VNIC 0. Okay, so now 0 goes to 0, 1 goes to 1. Okay, and it's using the first adapter, which is going to be on the A fabric by default. Okay, so what I'm now going to change is we're going to add an IP address. So let's go up to the 5Ks, and the 5Ks are going to be using VLAN 10. If we look at the show spanning tree for VLAN 10, we have VLAN 10 forwarding east-west between the 5Ks. Okay, so if we look at the show LLDP neighbors, we should see that on ports E13 and E14, this is going to 5K2. And then port E19, which is an edge port, E19 is forwarding us down towards the fabric interconnect. Okay, it's port 1/3 on the FI's point of view. And then likewise on 5K2, if we do the same thing, show spanning tree for VLAN 10, we're forwarding it east-west over ports 3 and 4, and then show LLDP neighbors, port 1/9 should be going down to fabric interconnect B. Okay, so right now if we go back to our physical topology, we're sending traffic out of fabric A, out port ETH13. ETH13 is then going to ETH19 on the other end. And between the two of these, we have 1/3 and 1/4. Okay, likewise on the other side, we're going out E13, and that's going to E19 on the other side. Okay, so next let's configure a subnet. So on the 5Ks, we're going to go to global. We'll say feature interface VLAN. We're going to create interface VLAN 10 and give it an IP address. Okay, let's say 10.0.0.51/24, no shut. And then on 5K2, we'll say the same thing, feature interface VLAN, interface VLAN 10, IP address 10.0.0.52/24, and then we're going to run HSRP. Okay, so on both of these, we'll say, let's save our marker, or say where we're at in the parser. So push, we're going to say feature HSRP, and then interface VLAN 10, HSRP group 10 has an IP address of 10.0.0.254. No shut. Okay, that's going to be our gateway. So if we show HSRP pipe to include the state, we should see that one of them is going to be active, one of them is going to be standby. Okay, so 5K1 is standby, 5K2, if we actually didn't apply there, let's look at this show CLI history, unformatted, show me the last, let's say 20 lines. Okay, so I need to add that. Okay, then on the VLAN interface address is 10.0.0.52 on this side. Okay, let's show HSRP pipe to include the state. This guy is listening. Show HSRP pipe to include state. Speak, and then we should see it go to either active or standby. Okay, so 5K2 is the standby router, 5K1 is the active router. So let's ping 10.0.0.254. Okay, which we can reach. Okay, additionally, we have the connection that goes from 5K1 to the Windows VM, okay, so server 1. This is the jump box that I'm connecting to the UCS manager from. So on this interface here that goes to 5K1, I'm also going to put an address, let's say it's 10.0.0.11/24, just so we can use this to manage the UCS blade, or more specifically manage the OS, which is going to be VMware. So on 5K1, this is going to be port 1, E11. So let's go to show run interface E11. Interface E11 we'll say is switch port host and switch port access VLAN 10. Okay, so it's an edge port in VLAN 10. Then from the server's point of view, I'm going to go to the network properties. So network connections, the link to 5K1, go under properties, IP. I'm going to set the address to be 10.0.0.11/24. Gateway is 10.0.0.254. Okay, so from here, I should be able to ping to 10.0.0.51. Okay, and ping 10.0.0.52, and then also the virtual IP 10.0.0.254. Okay, so basic LAN connectivity of the 5 case is working. Okay, now we're going to configure an IP address on the server. So from VMware, we're going to go to, so we're under Configure Management Network, we're going to go to IP Configuration, and then we're going to statically set the IP. So let's go down to statically set the address. Okay, address is going to be 10.0.0.101/24. Gateway is 10.0.0.254. Okay, then escape. Should say, do you want to apply these changes? Yes. Escape, escape. And then we should see on the main splash screen, it says our IP address now is statically 10.0.0.101. Okay, so let's see from the Windows VM, can we now ping this address? Ping 10.0.0.101, which we can. Okay, next let's look at how are we actually forwarding this traffic through the Fabric Interconnect. So from the Windows machine, we need to look at the ARP cache, figure out what's the mapping between the IP address and the MAC address, then go to the layer 2 switches, look at the CAM table, show MAC address table for that address, and then figure out what port that we're dynamically learning that on. So under Windows, let's say ARP-A. Okay, that's going to show us the full ARP cache. And the destination is 0025B50009F. Okay, is the MAC address that it's being used. Okay, so let's go up to 5K1. And on 5K1, let's find this in the CAM table, okay, in the MAC address table. So let's say show MAC address table, pipe to include 9F. Okay, we're dynamically learning this on Ethernet 1.9. Okay, this is the address. Show MAC address table let's look at all the dynamic addresses. Let's say dynamic addresses on interface E19. And then the same thing on the other side. So let's go to 5K2. Show MAC address table dynamic. We're not learning anything from the blade. Okay, if we look at the show MAC address table for VLAN 10, we see the dynamic address of the 009F, and it says we're forwarding this on port 1/3. Okay, 1/3 from 5K2's point of view is saying go that way in order to get to the host. Okay, so as we would expect, since I had configured the VMNICs to match up with the naming convention of the VNICs, VMNIC 0 maps to VNIC 0, VMNIC 1 maps to VNIC 1, and I did it under the VNIC VHB placement policy. VNIC 0, VNIC ETH 0 actually, is pinned to Fabric A, which means that the MAC address should be being learned by Fabric Interconnect A. Okay, and the two hosts that we're trying to send the traffic between, from 5K1's point of view, if we look at the show MAC address table dynamic for VLAN 10, is going to be this 3D98 address, so that's the Windows jump box, and then the 009F, that's the VMware management IP. Okay, so from 5K1's point of view, it's saying I'm going out E11 to get to the Windows jump box, and I'm going out E19 in order to get down to the VMware server. Okay, so let's look at this also on the Fabric Interconnect. We're going to look at the same thing. So we're going to connect to NXOS and then show MAC address table for VLAN 10. Okay, we see we have a couple static addresses. We also have a dynamic address. So the dynamic address here is being learned on Virtual Ethernet 702. And if we look at the show interface VETH 702, this should physically be mapping to chassis 1, slot 4, and then the virtual adapter VNIC ETH 0. So now as we go from the Fabric Interconnect A southbound to the I/O module, we're going to take our entire Ethernet frame. Okay, Ethernet is going to have our IP packet inside of it like a ping, and then we're going to put this inside a VN tag. So the VN tag frame goes down to the I/O module. The I/O module looks at the destination virtual interface and figures out, hey, that's actually virtual Ethernet 702 that I need to forward down to slot 1 or chassis 1 slot number 4, which is really the ESXi address. Okay, now somebody asked a question here, and it's actually a really important one here. shouldn't the MAC address end with 8F for the IP address? Okay, notice if we go back and look at the show MAC address table for VLAN 10, I'm learning 8F and I'm learning 9F. Now the issue I'm running into is that when VMware was installed, the NIC order was backwards. 9F was on the A fabric, 8F was on the B fabric. So this means that when it assigned its own internal MAC address to the virtual VM kernel, it was borrowing the MAC address from the interface. But the issue I'm going to run into now is that this MAC address already exists on the B fabric. It's already overlapping to some other number. So either we need to go to VMware and then refresh the NIC so that it's not choosing that particular number, or we would have to assign a new MAC address to ETH1. Okay, so VNIC ETH1 on fabric B. Otherwise, we would have overlapping numbers. What this really means is that I should have changed the PCIe VNIC VHBA placement policy before I did the initial association. Because once I did the association, it now learns those MAC addresses, and then that's going to be delivered down to the OS. Now, I believe that from a VMware point of view, I can reset this by doing this. So let's go back to the GUI. Let's go to the VMware console. Okay, hit F2 to customize. Log in as CCIE DC01, and then I'm gonna reset this the virtual switch config. Okay, so I'm gonna go to restore or network restore options, restore network settings, yes. Okay, that's gonna delete all the networking config. Then I'm gonna go back to configure management network, network adapters. I'm gonna use the first one, so the 8F. Then I'm gonna go to IP config, statically set the IP address to 10.0.0.101, or let's say 102. Okay, so we make sure that we have a new ARP that's going through. /24, gateway is 10.0.0.254. Hit escape, then yes to apply. Okay, then we're going to go to test the network, test the management network. Okay, so it's going to ping to 10.0.0.254. Let's also ping to 10.0.0.11, which is the Windows server. And let's say 10.0.0.52, which is going to be 5K2. Okay, so hopefully we should be able to hit all three of these. So gateway is okay, the Windows box is okay, 5K2 is okay, so everything's fine. Okay, if we now go to the Windows server, let's look at the ARP-A. We should see the .102 address. And notice now the .102 address is being mapped to the MAC address 8F. It is being mapped to the correct value. But the issue is that it was my order of operations that was wrong. That VMware learned the MAC address based on the NIC that we're physically giving to the OS, and the OS is not refreshing that. So we would have had a black hole for traffic that was meant to be going to the B fabric going to 9F that would have switched the wrong direction because it was pointing out the wrong virtual Ethernet. Okay, so basically the lesson from this is it's an order of operations problem. I should have changed the PCI placement first before I did the initial association, or like I did in this case, just delete the networking config and then replace it. Okay, so what's really key about this example though is that if we notice from the Fabric Interconnect, when we look at the show MAC address table for VLAN 10, what do we not see here? We don't see any of the MAC addresses that are pointing out Ethernet 1/3. Okay, 1/3 was the physical link that we were using from the FI in order to get to the 5K. If we look at the show LODP neighbors, we should see that locally E13 is going to E19 remotely. When we then looked at the show pinning for either the interface VETH, in this case it would be VETH 702, which is this number here. So either show pinning interface VETH 702, or I could say show pinning for the border interfaces, or show pinning for the server interfaces. Effectively, these are all showing the same output, it's just a different format. Okay, this one here, show pinning server interfaces, says what are all the downstream facing links. So these are southbound that are going to the blades. Okay, so from the Fabric Interconnect on the server ports going southbound. Okay, so it has a MAC address for itself in the supervisor. This is going to be like the management IP. And then we have the virtual Ethernets. This is going to be the actual blades. So we're saying as traffic comes in from the virtual Ethernet, and it's going northbound to leave the fabric interconnect, we're going to force the traffic to leave via Ethernet 1/3. Okay, the reason why right now is because we only have one interface configured. But under most cases, you're going to have more than one link for load balancing and for redundancy. Okay, so what I'm going to do now is to activate another port, which if we look back at the diagram, this is going to be port number 4 on the A fabric. Okay, so we're going to have two possible interfaces that we could go out, E13 or E14, and then those are corresponding to ports 9 and 10 on the 5K side. Okay, 5K again is not doing anything important with its config. If we look at the show run at interface E1 9 to 10, the only thing it's doing is just saying switch port mode trunk, and spanning tree port type is edge trunk. Okay, so let's say on E110, I'm just going to say switch port mode trunk and no shot. Okay, that's it. Now, from the fabric interconnect point of view, we need to configure this interface as an uplink. Okay, so regular Ethernet uplink. So we're going to go back to the UCSM. Under equipment, we're going down to fabric interconnect A. Then under the fabric interconnect A, we're going to go to the uplink Ethernet ports. Okay, we're just the Ethernet ports. We're going to go to port number 4. And right now it says port number 4 is admin down. Okay, so it's blank. Okay, role is currently unconfigured. So I'm going to say reconfigure it as an uplink. The role now changes to network. Okay, so it's facing towards the rest of the network. And what this really means behind the scenes is that it's making it a trunk. Okay, so on FIA, if we look at the show run interface E1 3 to 4, both of those simply say switch port mode trunk. The allowed list for the VLANs are going to be any VLANs that are created, which right now is only VLAN 1 and VLAN 10. Okay, the next step is that we're going to look at what happens when there's a failure of the uplinks. Okay, so right now I have two interfaces possibly on the A fabric, one interface possibly on the B fabric. So if we look at from 5K1's point of view, let's first ping the server. Okay, server is 10.0.0.102. Then look at the ARP cache. Show IP ARP, pipe to include 10.0.0.102. We see what MAC address this is mapping to. We'll then look at the show MAC address table for the address, this guy. And this is pointing us towards E19. If we show LLDP neighbors, E19 is going towards Fabric Interconnect A, port number 3. This means that from a pinning decision, the virtual NIC or the virtual Ethernet that the blade is created is statically pinned to Ethernet 1.3 as its uplink. Now, if the interface goes down, as long as there's an alternate interface that is trunking that VLAN, I should be able to move the traffic over from one port to another. Okay, so let's go to the Windows box and let's do a ping that's going to the VMware box. Okay, so .102, and let's keep this ping going. Okay, so -T. What I'm now going to do is go to the 5K, shut down port 19, and if everything is working properly, we should see the MAC address move over to 110 because it has an alternate path that's reachable on that fabric. Okay, right now we haven't configured fabric failover under the NIC, so we just have all of the default settings. So on 5K1, we're going to go to global, we're going to go to interface E19, shut it down, and then hopefully if everything's configured right, we should see that we don't have a packet loss or don't have much packet loss. Okay, so timed out, then it came back. Okay, so it's not sub-second failover, but it's, fairly quick. Okay, if we now look at the show MAC address table, we see now that we're learning the MAC address out port 10. Now, if port 9 were to come back, no shut, and we look at the MAC address table again, the MAC address is not going to move from 10 back to 9. So once the pinning decision is made, it's going to stick on that link until there's a failure, and then it needs to move over to another alternate path. Okay, so unless you either reboot the blade or shut the interface down, bring it back up, the pinning decision is going to be static once it's made. Now, the disadvantage from this design point of view, though, is that I'm not load balancing between the two interfaces. So if this server is saturating 10 gigs on port number 10, and there's also another VNIC that is pinned to the uplink E14 from the Fabric Interconnect's point of view, then we're going to be contending for the same uplink bandwidth. Now, ideally, we would just have these in a port channel, and then we would load balance to the port channel. That is one of the options, and that's going to be typically the most common design from a network connectivity point of view. That we would have dedicated links for Ethernet connectivity and separate dedicated links for storage, where our final optimal design here, we would have a virtual port channel that's built between the 5Ks. Okay, so the 5Ks are going to have the peer link between them. They're going to have the peer keep alive, and then the member ports are going to be the interfaces that are going down to Fabric A. So on 5K1, this is going to be ports 9 and 10, and port 11 on 5K2. So these two together would be VPC 1. And then the other 3 ports, so ports 9 and 10 on Fabric B, or 5K2 I should say, and then port 11 on 5K1, these would be in VPC 2. Then from the Fabric Interconnect point of view, it's going to see just one port channel between these 3 interfaces on A. It's going to see one port channel between these 3 interfaces on B. Then when we go to make a pinning decision, all of the pinning is going to point to the logical port channel, which means that if we want to add more links or if there's a failure and links are removed, the virtual NIC is not going to have to repin. So we would see that the failover is going to be even faster. It should lose no traffic as it moves from one port to the other, because what it's updating is just the port channel hashing as opposed to the repinning decision. Okay, the repinning decision is basically a hardware programming where it has to delete the old entry and then reflash the new entry in the hardware fib. But in this case, with port channel load balancing, it's already written those entries for the logical channel out multiple members. So the only convergence we would have is just how long does it take for us to figure out that the physical link is down. It was generally is going to be very fast, like less than 25 milliseconds. Okay, so from the FI's point of view again, the key takeaway for this is that when we looked at the show MAC address table for VLAN 10, we're only learning the southbound MAC addresses, we're not learning the northbound MAC addresses. What this ultimately allows us to do is to scale the system higher. Because now we only need to worry about the TCAM space, or essentially the memory that is dedicated to the ASICs. We only have to worry about the MAC addresses that exist on either bare metal blades, bare metal rack mount servers, or virtual machines that are either in the B chassis or the rack mount servers southbound of the FIs. We're not going to have to learn about the northbound default gateways. We're not going to have to learn about any other VMs or physical machines north. We're simply going to make that static pinning decision that says when any traffic comes from the blade, okay, so let's say we're going to look at the show interface pipe to include virtual Ethernet or server. This is going to show me quickly the mapping between the downstream vETHs in the physical blade. Okay, so vETH 698 is mapped to server 1.5, vETH 702 is mapped to server 1.4. Okay, server 1.4, this is the one that I have configured as 10.0.0.102. So to trace where this traffic is actually coming and going to, we would look at the show pinning for vETH, for interface, vETH 702. It says this is pinned out E14. If we show CDP neighbors on interface E14 or show LLDP neighbors, it says this is going to 5K1 port 10. So this means, again, that we go to 5K1, we look at the ARP cache. The ARP cache is telling us that this is the MAC address, the 8F. We look at the MAC address for that address, and where it should be pointing is on E110. So effectively, the FI is doing like static routing, but it's static routing for Ethernet switching as opposed to IP routing. So any packet that is received in from the blade that comes in that VNIC, or in other words, the vETH, is statically routed upstream out port 1.4, which also means that the return flow is always going to come in that direction. Because from 5K1's point of view, it didn't yet know the MAC address of the end host until traffic was flooded onto the Ethernet LAN. So from 5K1's point of view, it basically says I have multiple trunks that are going southbound to the access layer. I have port number 9 and I have port number 10. The MAC address X of the blade came in and the traffic was flooded out E14. Okay, that was based on the pinning decision. This now means that from the 5K's point of view, it's going to see MAC address of X is located out port E110. So now if we were to have an IP packet come from the northbound network, get to 5K1, 5K1 does a lookup, say, okay, it's going to the MAC address of the server. I'm then going to switch the packet out E110. This matches the pinning link of the UCS, so it means that the reverse path forwarding check is successful, and we're then allowed to forward traffic southbound down towards the blade. Okay, we'll see that there can be cases where this check is wrong and it ends up traffic black holing. But under normal circumstances, if the network is fairly simple in terms of its physical wiring, like all of the interfaces from FIA's point of view are going to the same switch. They're all going to 5K1, so it doesn't really matter which interface we pin to, we're still going to the same box. Now ideally, again, we would put those on a port channel so we can load balance, but at least from a basic connectivity point of view, we don't have a traffic black hole. We are able to reach the destination. Again, we saw that from the server, we can still do the pings. Okay, in the next section, we'll talk about what are some of the problems that we could run into with this when the LAN design is a little bit more advanced, and then how does the system deal with pinning to multiple uplinks at the same time. So I can go to E13 or I could go to E14. How do I choose to go one versus the other? And if I choose the wrong link, what's going to be the end result from the northbound network? And we'll see, and once we start to get into this level of detail behind the scenes, this is what is unfortunately not very well documented, how to do the verification from the CLI and how to figure out, is it an issue on the blade, is it an issue on the UCS, is it an issue on the northbound switch, as to why I'm actually not getting connectivity down to the final end host.